Today we are going to discuss about the probability. Here the particle behaves like birds. There is always uncertainty in position. Therefore, the probability is calculation of probability is very much important. This is defined by the probability of existence from point P1 to P2 is given by this expression. The integral from P1 to P2 psi star psi dx. So this is defined as the probability of finding the particle between any two limits. Now first we consider one-dimensional box. This is unsymmetric problem. Now let us calculate the probability of finding the particle between any two limits if the particle is in the ground state. For the nth state wave function we have already determined sin of x is equal to square root of 2 by L sin n pi x by L. If you put n is equal to 1, this is a ground state. So sin 1 of x is equal to square root of 2 by L sin pi x by L. So this is since we are interested in calculating the probability of finding the particle in the ground state, that psi 1 is needed. Now the product of finding the particle between the limits x is equal to 0 to L by 2 is defined by integral. The lower limit is 0 and the upper limit is L by 2, and here you have to substitute psi 1 star psi. So square root of 2 by L sin pi by x into psi 1 star is again you will get the same value because it's a real function. So this is the constant can be taken outside from this integral. So 2 by L can be taken outside. So 0 to L by 2 sin square pi x by L dx. Now this can be evaluated since this is a sin square function. So that can be first expression in terms of 1 minus cos 2 pi x by L whole divided by 2. Sin square can be replaced by 1 minus cos 2 pi x by L whole by 2 because we have to use the expression cos square theta minus sin square theta is equal to cos 2 theta. So using that expression, sin square function can be replaced by this one. Now this can be evaluated because there are two terms. First term, once we evaluate, this is 1 into dx is equal to x. Then you want to substitute the limits. You can get the value. The second term, once we integrate, this term becomes a sine term. If you apply the limits, lower limit as well as the upper limit, the sine term becomes 0. So once we evaluate this integral, this becomes L by 4. So 2 by L into already is there, and we evaluate this integral. This is L by 4. So finally we will get the 1 by 2. So the probability of finding the particle in the ground state, if the particle is in the ground state, between the limit 0 to L by 2 is found to be half. Similarly, you can calculate the probability of finding the particle between the limits x is equal to 0 to L by 4. So for 0 to L by 4, the lower limit is 0, upper limit is L by 4. You have to repeat the same procedure. Then the result is 1 by 4 minus 1 by 2 pi. This is the result. The probability of finding the particle between 0 to L by 4. Any limits within this one. So L by 4 to L by 2, if you want to calculate, the lower limit is L by 4, upper limit is L by 2, and this is sin square pi x by L. Sin square pi x by L is replaced by 1 minus cos 2 pi x by L divided by 2. And after evaluating the integral and substituting the limits, the result is 1 by 4 plus 1 by 2. Between the limits L by 4 to 3 by 4, then the probability of finding the particle in the ground state is calculated as 1 by 2 plus 1 by half. Similarly, between L by 2 to 3 by 4 L, the probability is found to be 1 by 4 plus 1 by 2 pi. And between 3L by 4 to L, between these limits, the probability is calculated as 1 by 4 minus 1 by 2 pi. So if you summarize the result here, so this is our L, and the width of the well is L, the origin is 0 because this is an unsymmetrical. This is divided into 4 regions. Okay. L by 4, L by 2, 3L by 4 and n. Between 0 to L by 4, this is the probability that you have calculated P1. Between L by 4 to L by 2, this is the probability 1 by 4 plus 1 by 2 pi. P2 is the probability. Between the limits L by 2 to 3L by 4, P3 is the probability. Between 3L by 4 to L, P4 is the probability. Now, if you want to calculate the probability of finding the particle between L by 4 to L, from this result you can also write because P2 plus P3 plus 4, P4. So, once we add the probability of finding the particle from here to here. Then once we add all the values, then you will get the total probability, which is must be 1. So, you can see that this is 1. That means that the probability, the particle is always within the well. So, the probability of finding the particle within the well must be 1. Now, if you choose a well as a symmetrical, the origin is at the middle of the well, 0. There is L by 2 this side and this is L minus L by 2 this side. The total number of the well is again L. Now, here let us calculate the probability of finding the particle. The particle is the ground state. Here the ground state wave function is a cosine form. Psi 1 is equal to square root of 2 by L cos pi x by. This is the ground state wave function. For this problem, it is square root of 2 by L sin pi x by. This is the ground state. So, psi 2, if you take psi 2, this will be a sine. Psi 3 again will be a cosine and so on. That we have already discussed. So, you take the ground state wave function. Here, if you want to calculate the probability of finding the particle is ground state. If it is between the limits minus L by 4 to 0. So, if you want to find this probability, then you substitute psi 1 star psi dx between the limits minus L by 4 to 0. Here, since it is a cos square term, that can be replaced by 1 plus cos 2 pi x by L whole divided by. Again, cos square theta minus sin square theta is equal to cos 2 theta. So, using that expression, the cos square can be replaced by 1 plus cos 2 theta x by 2 pi x by L whole divided by 2 dx. Now, this can be easily evaluated. Once we evaluate this integral, this value becomes 1 by 4 plus 1 by 2. So, 1 by 4 plus 1 by 2 pi. This is the probability of finding the particle between these two limits. So, similarly, between these two limits, 0 to L by 4, if you calculate, you will get 1 by 4 plus 2 pi. Between the limits L by 4 to L by 2, this is the value P4. 1 by 4 minus 1 by 2 pi is the probability. And minus L by 2 to minus L by 4, and this is the probability. Again, if you add all the values, the probability of finding the particle, any value within this value is the sum of all the probabilities P1 plus P2 plus P3 plus P4, which is 1. That means the particle is always within the well. The probability of finding the particle within the well must be 1. So that will be easily checked. Now let us take two problems. These two problems are already asked in the NET examinations. You take this problem. Consider a free particle confined to one-dimensional box with d of x, the potential is equal to 0. Between the limits x is equal to 0 to L and infinity elsewhere. The probability of finding the electron in the nth state from x is equal to 0 to x is equal to L by N. So here this is an asymmetric problem that we have already discussed. Because here we have to calculate the probability of finding the nth state. Since it is the nth state, we have to take the nth state wave function. The wave function corresponding to the nth state for a asymmetrical problem is sin is equal to square root of 2 by L sin n pi x by. So what is the probability? Probability is psi star. So psi n star psi n into dx, and the limit is from x is equal to 0 to L by 0 to L. So again, this is, since it is a sin square function, that can be replaced by 1 minus cos n pi x by L whole divided by 2. Then it can be integrated easily, and after substituting the limits, you will find this value is calculated as 1 by n. So this is 1 by n. So the option B is the correct one. The next problem is So far we have discussed one-dimensional problems. Now here we are considering a hydrogen atom problem. An electron is in the ground state of the hydrogen atom. The probability and that is within the Bohr radius is approximately equal to 0.6, 0.9, 0.16 and 0.3. So this is electron is revolving around orbit. The radius is r. Since this is electron is in the first Bohr orbit, so the radius is equal to n0. The n0 is called the Bohr radius. Now since the particle is in the ground state, you have to take the ground state wave function of the hydrogen atom. The ground state wave function of the hydrogen atom is psi1 of s. The one state, the 1s is the ground state. 1 by square root of pi n0 cube within the square root e power minus r by n0. So this is the ground state wave function. Now the probability is here psi star psi deta, because this is a one-dimensional problem. Therefore psi star psi dx, because psi they are one-dimensional wave function. Here it is a three-dimension. So you have to write down deta. Deta is the volume element. Since it is a volume element, the volume element can be replaced by r square dr sin theta d theta d phi. R varies from 0 to n0 and the theta varies from 0 to pi. The pi varies from 0 to 2 pi. So you substitute psi1 star and psi1 and r square dr d theta d phi, and you have to evolve the three integrals. R varies from 0 to n0, theta varies from 0 to pi, pi varies from 0 to 2 pi. First let us evaluate this d phi. D phi, once if you evaluate d phi, the result will be 2 pi. And again, the second step you have to evaluate the theta part. Sin theta d theta integral from 0 to pi is 2. So if you evaluate the angular part, it becomes 4 pi. So first we evaluate this value 4 pi divided by pi n0 cube, and the remaining part is the radial part 0 to n0 e power minus 2r by n0 r square. Now this integral can be evaluated in a single line. So this is a exponential part and this is a polynomial part. First you write down the polynomial part within a bracket. Then the integral part you have to integrate. So e power minus 2r by n0 by minus 2n0. This is the first step. Then change the sign. You put a negative sign here, minus sign here. Then you differentiate this part. R square you have to differentiate. So you put 2r within the bracket and you integrate the integrated value. So you have to integrate again here and you write it within this bracket. E power minus 2r by n0 by minus 2 by n0 whole square. Then change sign. Since it is a minus, you have to change sign. So this will be plus. Then you have to differentiate the value within this bracket. It's a 2r. If you differentiate, this becomes 2. And here, the integrated value here, you have to integrate it again. If you integrate again, this will be e power minus 2r by n0 minus 2 by n0 whole cube. Then the next term is you have to put a minus and you have to differentiate this part. If you differentiate the constant part, it will be 0. So once you attain a constant here, then you have to stop. So you will not go further, because once if you go further, it will get a 0. So you have to stop up to here. So plus, minus, plus. So alternatively you have to change the sign. Then after evaluating this integration, you have to apply the limits 0 to n0. Lower limit is 0, upper limit is n0. Once you apply the limits, the value of p is equal to minus 5 e power minus 2 plus 1. That is 1 minus 5 e power minus 2. You substitute the value of e, then you can calculate this is 0.32. So the probability of finding the particle within the Bohr radius is 0.32. The option D is correct. So from the definition, so this is one-dimensional case, this is a three-dimensional case. So the definition is the same. So depending upon the dimension, whether you want to choose a dx here or here you have to choose a volume d tau. So this question was also asked in your previous year NET examinations. Now other important problems will be discussed in the next class.